Live from the North Carolina Museum of Natural Sciences in beautiful downtown Raleigh, it's the Science Cafe with your host, Chris Smith.
All right, everybody. Good evening, everyone. Welcome. Thank you for coming out to the Science Cafe here at the Museum of Natural Sciences. My name is Chris. I'm the host for the Science Cafe here at the museum, and it is my pleasure and privilege to welcome you all to our weekly Science Cafe events. Every Thursday night, we all gather right here. At least everybody should be gathering with us right here. Yeah, thanks for laughing. Should be gathering with us here in the Daily Planet Cafe for a chance to figure out what is going on in the world of science, technology, engineering, mathematics, and even sometimes the arts, and how it relates to our daily lives. So what's going on out there? Why is it important to us? And how can we learn or do more about it? The Science Cafe happens every Thursday, 7 o'clock, right here. There's no reason that you shouldn't be here every week. Topics cover just about every aspect of the sciences that we think is interesting, and we think a lot of things in science are interesting because we're a science museum. Go figure. Tonight, we're going to be talking about a little bit of what is happening. Not even, I guess it's happening right now, but it's more looking out into the future of what's happening in the world of science and technology and what the implications are for what some of that science and technology are going to be. So for tonight, we brought out more than one person to give us some insight into not only what's happening with the science, but what that could mean for us, how we should think about it, who makes the decisions. If something that science wants to do could be dangerous, we should probably be thinking about that, right? We should probably be, yes, thank you. We should probably maybe plan for that instead of letting some science just sort of happen and then figuring it out on the back end, which is the way that I tend to operate. And lack of planning often creates some issues, right? So raise your hand. I'm not going to ask you if you plan your life out. Raise your hand if you would want a self-driving car. Yeah. Raise your hand if you've ever sat in traffic on 40. Okay. All right. Raise your hand if this is your first time to the Science Cafe. Okay, fantastic. Give those people a round of applause, because they're being very gracious at listening to me talk. Tonight, to talk about self-driving cars and thinking about all the things that we need to think about if we're going to get vehicles that move and think and act on their own, we've got three experts from Duke University who together are working at the intersection of ethics, philosophy, computer science, economics, to try to sort out what some of these issues are, how they apply to us, and what the future looks like for technologies that can seemingly think and make decisions on their own, like self-driving vehicles. So the first person you're going to meet is Dr. Vincent Conitzer. He is in computer science and economics, both at Duke University. Then we have Dr. Walter Sennett Armstrong, who's a professor for practical ethics at Duke University. And then third up will be Janna Scheik-Borg, who's in neuroscience at Duke. So we've got a very interesting night planned for you tonight. Now, of course, they're each going to talk for a few minutes, give us some insight into what they know and what they're thinking about on this frontier. And then once they've finished, I'll be back up, I'll have a microphone, and I'll have one of my colleagues with mics, and we're going to flip it. We're going to go from them talking a lot to maybe you talking a lot. You'll get the chance to ask your questions, what you think is interesting, and what you want to know about this topic of the experts that we have on stage. So I'm going to bring them on up to the stage, give them a warm round of applause as they make their way up.
Is this good? Oh, good. There you go. Good. So my name is Vince, and I'm an artificial intelligence researcher. So I thought I would talk a little bit about artificial intelligence in general, all the progress that has been made in the field recently, which is, of course, one of the things that has enabled self-driving cars to be considered at all. So how do you measure progress in AI? There's many different ways. One fun one is to look at games. So one way that AI researchers have benchmarked themselves for a long time is in how well they can defeat human players in various kinds of games. So you might think back to 1997 when Deep Blue defeated Kasparov in chess. More recently, all kinds of other games have been falling. So back in 2011, IBM's Watson actually managed to beat the top human Jeopardy champions, Brad Rutter and Ken Jennings, which to me was really amazing. I did not think that that would be solved so quickly. And there's a question of whether it's really solved. If you look at those games, Watson also gave some really strange bad answers at times, but most of the time it did actually pretty well. More recently, Google's DeepMind managed to start to play Atari video games. If you look at the screen, you see this old Atari game computer, of which I had one as a kid as well. And so it's learning to play those games just completely on its own, and in many games it's actually reaching human level performance. Even more recently, Google DeepMind, again, they produced AlphaGo, which defeated Lee Sedol, who was one of the best Go players in the game of Go. And the game of Go had always been much more difficult for computer programs because there are so many moves you can take in that game at the same time, and it seems to be a little bit more about intuition, what is a good state of the board, rather than chess where you kind of think ahead. It's more about how many steps you can think ahead. Nevertheless, AI has become better there as well, and Lee Sedol, I think, now is going to be remembered mostly for the various pained expressions he's making in those pictures. And then even more recently, I don't think this one got as much attention, but the game of poker, that's an interesting game as well, because a different aspect of it is that it's a card game, and so you don't know exactly what is the current state of the game, right? Like a game like chess or Go, you know exactly everything that's going on. You might not know what the other person is thinking, but you know everything that's going on in the board. Whereas a game of cards, you don't know everything. You don't know what cards the other player has. And that makes it a sort of fundamentally different kind of game. But there too now, AI is defeating the top human players. I'm a little bit partial to this one because that work came out of my PhD advisors group at Carnegie Mellon. And if you see the guy kind of in the background over there, I was on his PhD committee. So a little bit of bias there. So that's one kind of place that there's been a lot of progress in AI is in game playing. Meanwhile, there's been a lot of progress in other areas as well. Image recognition, right? How does Facebook know who is in those pictures that you upload to Facebook? Voice recognition, speech recognition. If you haven't tried dictating something to your phone in a while, try it. It's actually gotten really good. So there's all this amazing progress, and whenever there's some kind of some benchmark that's been reached, some progress that's been made, you see these articles in the news, and they're usually accompanied by a picture. Sorry, this is not working. No. Computers. Maybe just the battery. There you go. So usually it's accompanied by a picture like this one. This was actually accompanying some article on this poker playing program that I just told you about. Now, knowing something about how that poker playing program actually works, I can guarantee you that it's not suddenly going to do that. But there is actually a group of people that is seriously worried not about the poker playing program, but about AI in general, and whether it might actually start exceeding human intelligence in a broad way. So in some sense, it's already exceeding human intelligence on very narrow domains, right? Computers are now better chess players than we are, but we don't seem to care that much about that. But if they really became broadly more intelligent than we are, that might be a concern. Flip slides or... There you go. And those concerns have recently been in the news as well. A lot of that started with Nick Bostrom, who was a philosopher at Oxford and also a buddy of Walter, who wrote this book a couple of years ago called Superintelligence. And it is about this premise of, well, maybe at some point we'll actually build something that is broadly more intelligent than human beings. And if so, what can we expect to happen from that point? And what can we do now to guide that in good directions? And it's actually it's a very carefully reasoned, it has to be very speculative by the nature of it, but seems to be quite carefully reasoned, an academic kind of book. But somehow it became a New York Times bestseller. It influenced a bunch of people, including Stephen Hawking, Bill Gates, and also Elon Musk. Elon Musk in particular gave money to this Future of Life Institute to fund AI researchers to keep AI safe. And we actually got some of that money as well, full disclosure. And more recently, there's a book by Max Tegmark, who's one of the founders of this institute, called Life 3.0, which kind of builds on these themes as well, if you're interested. These kind of ideas are actually quite controversial in the artificial intelligence research community, the kind of traditional AI researchers, who are generally a bit skeptical about this premise of super intelligent AI. Some think it will never happen, it might happen a couple decades from now. It's a little bit hard to think now about what exactly that might look like. But in any case, even most mainstream AI researchers do think that there are things to worry about. So if we can go to the next slide, there are various near-term worries. So even though most AI researchers are skeptical that we're really going to see something from AI research coming out that would be broadly more intelligent than human beings, even not quite that intelligent AI could create lots of problems in society. One is through technological employment. This certainly ties into the self-driving car issue as well, right? If we can get self-driving trucks, that's going to put a lot of people out of work. So I put a few comics up here, but they're serious issues, right? Another one is autonomous weapons. So autonomous weapons are weapon systems that can act with minimal human input. And to some extent, we already have autonomous weapons, right? A cruise missile acts in some sense on its own. But as you amplify that and have systems that can more and more act on their own, it might change the face of warfare as well and could be very risky as well. And then finally, of course, self-driving cars. Besides the technological and employment issue, there are many other impacts that they could have. And that's what we're going to talk about today, right? So if a self-driving car gets into an accident, who is responsible? How do we want it to make trade-offs if it has to make a trade-off between the safety of its occupants versus pedestrians? Those kind of questions. So that's what we'll mostly talk about today, but it's against this broader backdrop of progress in AI. The broader question I've been doing a little bit of popular writing on. You can go to my website, which you can find just by Googling my name. And you can find all these articles on my website if you're interested. But now let's move on to Walter. So let's see. Oh, there you go. It's in order. It got put in order. But I went too far. Oh, there you go.
So I get that too. Hi, so I'm Walter, and I'm not a computer scientist or an economist. I do ethics, and so we're going to start talking about some of the ethical issues that get raised by autonomous cars. And Vince has already mentioned some of them, but I want to go through them a little more thoroughly, a little more systematically. Some of the issues are what I might call macro issues. They're issues about how the prevalence of self-driving cars will affect our society in general. The good news is that it's going to prevent car accidents. Of course, there's a lot of controversy about how many car accidents it'll prevent. People give wildly different estimates, but one figure that's often thrown around is 30,000 lives a year. That's a lot. You know, you think about it, introducing self-driving cars, if they replaced all of us. Now, why is that? Because we're all bad drivers, because we make mistakes, okay? Even when we're in top form, okay? Autonomous vehicles will, of course, still also have their own accidents. It's not like the rate of accidents will go down to zero, but if it prevents 30,000 deaths on the roads a year, that's a real moral benefit. Second, self-driving cars can be used by people with disabilities that would otherwise stop them from driving, and they'll be able to get around on their own, right? Blind people can take cars. There are people now in California, blind people, who are using self-driving cars to get to work, and now they've got a level of freedom that they never enjoyed in their lives before, which is another, great benefit. The third one that I want to add is maybe some people might think it's a benefit, others might not. We could take a vote on this, but they can also be used by drunk people, because if you want to go out to a bar and you're going to get drunk now, you have to figure out some way to get home, and some people don't bother finding a way to get home. Well, they're going to be a lot better off, and you are going to be a lot better off if they can come out of that bar as drunk as they want to be, push the button, and sleep it off in their car on the driveway in front of their house without hitting anybody on the way home. No more drunk driving accidents, no more drunk driving tickets. That's one way in which self-driving cars could prevent a lot of accidents. Finally, a little less obviously, a lot of people don't think about this. I actually had never thought about it before I read a little bit about it. Self-driving cars can reduce harm to the environment. Well, for one thing, you don't need a lot of parking lots, because after the self-driving car drops you off, your self-driving car can now go out and be an Uber for other people. And so you just saved a lot of parking spaces. But and you might not need as many cars on the road, and so you've saved a lot that way. But my favorite is trains. These self-driving cars, when they're going down the expressway, they can all signal each other, so they can follow 3-4 feet behind each other, get on the draft of the car in front of them, which means that they're not going to have as much wind friction, which means they're going to be much more fuel efficient. And you can have these long trains of cars going down the road that are all helping each other get down the road, and the total amount of gas used together is going to be less. To me, this is a nightmare, because I imagine myself like to the left of one of these trains trying to get off the expressway, But if they, at least accept my signals when I say I want to move right, then it could work out. So there can be a lot of benefits at the macro level. There are also going to be some costs. Vince mentioned the loss of jobs. It's not just for drivers, it's taxi drivers, it's going to be limo drivers, it's going to be truck drivers, it's going to be bus drivers, it can be airplane drivers if we want to, airplane pilots if we want to move there. You put all those together, and that's a tremendous number of jobs. One thing to think about there as an ethical issue is it matters a lot how fast it happens. If this happens over 30, 40, 50 years, people will probably be able to adjust, learn new skills, and so on. If that happens in 5 years, it's going to be a disaster for a lot of people whose livelihood depended on a job of driving. Self-driving cars also might reduce privacy. Just imagine, for example, the good news is when your teenager takes the self-driving car out, you can check in the morning where they went. And the bad news is that if you go somewhere that your spouse doesn't want you to go, then your spouse will be able to check where you went. And so privacy is going to be sacrificed if you can download this information. And it's not just members of the family who can download it. If it's up in the cloud somewhere, then other people might have access to that information as well. So there'll be losses in privacy. There'll be increased inequity as well. Who's going to be able to afford these cars? Rich people are going to be able to afford these cars, not poor people. And so if, in fact, they have fewer accidents, then that means that rich people are going to have fewer accidents than poor people, which doesn't seem fair if they're equally good drivers and so on. And finally, there's some fear that self-driving cars could be hacked and then could be used by terrorists as weapons against crowds. So you put all these together and you think at a social level, do we want large numbers of self-driving cars in our communities? Well, there's good news and there's bad news. The trick is always, in cases like that, to try to develop regulations which will reduce the costs and increase the benefits, and other plans such as retraining programs for drivers. That's going to be the real challenge as the cars take over on the roads. Now let's turn to the micro examples. Suppose that you're driving your automatic vehicle down. Suppose you're driving your automatic vehicle down a mountain road, and you go around a corner, and you see somebody in front of you. Now you have to make a choice. You either run that person down, or you drive off the cliff. Or you go, oh, no, I'm going to turn to the left. Oh, no, but then you hit a wall, bounce off the wall, kill them, and fall off the cliff. So what are you going to do? Are you going to put your welfare above the person on the street or the other way around? What if you've got one person in the car and there are two people on the road? What if there are two people in the car and one person on the road? So you have to look at the number of people, the location. Is it their fault? Are they supposed to be there? Are we supposed to figure out like how old that person is and how many years they have left? What exactly are the features that we're supposed to take into consideration? Any car that's equipped with artificial intelligence that looks at these issues and tries to solve them is going to have to figure out, first of all, which features to look at. If you go to the Moral Machine website, I don't think I can use the little, there's actually, I had a video from that website, but go to moralmachine.mit, is it mit.edu or something like that? It said MIT, so it might be moralmachine.mit or .edu. You'll be able to find it. And you can play a little game. You can actually change the people around. So you're in one of these emergency situations, and there are old people in the car and young people on the street, or young people in the car and old people on the street, or bank robbers on the street and priests in the car and babies on the street. And you can play around. And at the end of playing this enough times and varying the number of parties, it will actually calculate how much weight you put on various factors, such as age, such as criminal record, such as whether they're crossing the light illegally, and so on. Now, notice what this does is it tells you what your values are, and what we find is that different people that visit the website have very different values, so it's going to be a real challenge to figure out which of those values to put into the car. Mercedes says it's no challenge at all. Mercedes says, if we have to choose between our drivers and pedestrians, we choose our drivers. And the reason is that they're our customers, right? These people on the street, we never met them, they never give us $1. We're not gonna, who cares? So they said that one day, and then about 12 days later, they said, oh, no, we were misquoted, right? It was fake news. And so they took it back, and they took it back because they found out, among other things, that it would be against German law to do that, okay? To give a preference to the driver over the pedestrian. But nonetheless, in the US, a business could program its self-driving cars so it favors passengers over pedestrians. And the question then is, for the company and for you, is what do you think? Would most customers prefer to buy a car that favors its own passengers? What do you think? Do you think that you get a lot of customers for a car that did that? How many people think so? Raise your hand. Yeah. Okay, so how many of you would favor buying a car that favors the passengers over pedestrians? Come on, be honest. Okay. And then the question is why. We can talk about this if you want to. The question I want to raise is, should our laws allow that? Right? Should our laws actually allow car manufacturers to do that? And I want to argue no. And here's why. First I want to add, by the way, personally, I would buy the car that favored the pedestrian over the driver. And here's why. The odds of that actually making a difference are about 1 in a billion. How many times have any of you been driving down a mountain road, down the corner, and there's somebody standing in the road in front of you, and the only solution is to drive off the cliff? I mean, it just doesn't happen. And so in that one situation, maybe that program would help you, but in all others, it's not going to help you at all. Whereas if you know that you are the kind of person who would favor the pedestrian over the driver, partly because they don't have an airbag and you do, then you can sleep well at night, or at least I would, and so I would favor driving that car. Nonetheless, I predict that most people would drive the car that favors the passengers over the pedestrians. But if everybody bought those cars, there'd be a lot more deaths in accidents because the automated vehicles would drive into the pedestrians. And that's exactly the kind of situation where I think the legislature should step in, when our self-interest is going to lead a large number of us to do something which jointly is going to be very bad for society. So I would say that the legislators ought to prohibit it the way Germany does. I don't know that that's going to be really popular in America. I kind of doubt it, but I wanted to throw it out there as a controversial claim that we can talk about if you want. And now we'll turn to our third speaker, Janna. Shikeboard.
Okay, so first of all, throw something at me if the microphone goes too far away from my face. I have a tendency to do this. So I'm going to try really hard, but let me know if you can't hear me. So my name is Janna. I'm a neuroscientist and a data scientist, and I study how and why we as humans make our moral decisions. And Walter, we'll ask you questions later. So Walter talked a little bit about what the law should do. What I'd like to hear your opinions on are what companies should be doing, especially about these micro issues that he was just talking about. So especially because of all the issues that Walter discussed, at the end of last year, the government came out with some recommendations to the industry about what they should be doing with self-driving cars. And the truth is they didn't say all that much. But what they did say was, we know cars are out there already. We know they're making decisions that have ethical consequences. And we just want you to talk about that. We want you to talk about that, and we want to, as a society, come up with some type of solution. And in the meantime, we want you car companies to be transparent. Are you doing something like this? And if so, what algorithms are you using? So to me, that sounded pretty rational, but also not like a big deal. But it turned out that it was quite a big deal in the industry. And so this is just one example of the backlash that was given from the self-driving car industry. You can see the byline there, self-driving cars shouldn't have to choose who to protect in a crash. And this is just one of many. There's a whole flurry of articles like this. And over 6 to 8 months, there started to be some more nuanced views, like this one was more recent. In this case, they said, well, okay, maybe someday we should worry about ethical issues and some of these micro issues, but not because, don't make us do it now, first of all, and don't make us do it with algorithms. Let's just put the cars on the road, see what crashes happen, and once we see what crashes happen, then we'll know what's right and wrong, and then we'll deal with it then. That's what that article says. So it seems like there are some car companies out there, not all, especially because opinions are changing, but there are still some car companies out there that think car companies shouldn't have to think about ethics, and they shouldn't have to think about what their car is doing, and specifically how many people would live or die if they turn left or right. And ethics is another realm that doesn't belong in engineering. So this concerns me a little bit, because for me, I want to know that at least the car companies are thinking about this or care about it at some point. I want to know that if I'm going to spend a lot of money in a self-driving car, it's not going to do something that is completely against my moral values. And I'm not the only one. So this was a survey done, and they asked people, do you trust businesses in the self-driving car business to do what is right, morally right? And it turns out across the world, more than 50% of people say no. We don't trust them. And this actually increases in North America. So most people don't trust the car companies to do what's right. There we go. And so my specific concern comes a little bit from my engineering neuroscience background. When you make a model for something very complicated, it's very specific, and it's very hard to generalize it. So if you start by just solving one problem, it's very hard to extend that usually to solve another problem. And the picture I'm showing you here is one of the few that Vince didn't show. This is Deep Blue. This is the AI and the machine that beat Garry Kasparov in the late 90s in chess. So this was a great feat. It was an incredible team effort, cost a ton of money. As soon as the computer beat Garry in chess, it was put into a museum immediately, despite all that money. And the reason why is because everyone agreed it was not worth it to even try to make it do something else, because they knew it would be so hard. So that's my concern with self-driving cars. If the only thing we care about is to program them up so they don't run into things, I'm concerned that it's going to be very hard to program them to do anything else in the future. So I at least want us to be thinking about these things. There we go. So you can imagine a couple of things that the car companies might respond to this. One of the first things they say, which you hear a lot, is stop slowing innovation. And my quick kind of flippant response to that would be, if you've seen, we don't have them here yet, but self-driving cars are increasingly on the roads. They're in more and more cities. innovation is not being slowed that much, if it's being slowed at all, by thinking about other issues. So I don't think it's that much of a concern. Another thing they might say is, look, these are just edge cases. Let's not worry about them right now. And if anyone's in the engineering field, you might question that, because usually in that field, we care a lot about edge cases. You have to think about the edge cases. You focus on the real problem, on the hardest problems first, or the main issues. But if you're not thinking about the edge cases, you're not going to be able to solve them. So you at least want to document them and be thinking about them together as a team. So I don't think that's a very good argument either. The other thing that they might say is, well, they're not edge cases. They're just simply irrelevant. They might say something like Walter said, this will just never happen. So this is not worth their time. And the other thing they might say is, look, even if all of this is true, self-driving cars are going to save so many people. We need to get them on the road to save lives now. So I just want to explore our intuitions about those last two things just a little bit to see what you think about them. And let's start with the irrelevant one. Do edge cases, or kind of these things that don't happen that much, matter? So I want you to imagine that you are bringing your mom to the hospital, and she's going to have a knee surgery. And this is a simple knee surgery. It's almost guaranteed to work. There are hardly any risks. You should come out just fine. The surgeon comes out, and he says, I decided there were 5 other people who really needed organs in the emergency room, so I decided to use your mom's organs to save those 5 people. How many people would be happy with that? I didn't see any hands. So I don't think many people would agree with this cartoon if it ever shows up. And let me ask a separate question, okay? If that did happen, and you found out that that doctor did so totally legally, they would never get in trouble, and it could happen at any time, how many of you would be more nervous going into the hospital or getting a surgery? So I think this at least should call into question whether edge cases that don't happen often, especially when they have to do with life or death, matter to us. I think they do matter to us. So what about more people dying on the road? Now, I'm going to leave most of this to the discussion, but I just want to bring up a couple of thoughts about this. And that's that we don't actually know how many people will be saved. Let me just make a disclaimer. I am one of the people who do believe that self-driving cars will eventually save more lives. But how many and when, that's a different question. And there's a lot that goes into this. And there's a lot of research that's been happening in the past 6 to 8 months that even models out that there are going to be many issues. For example, once people know how self-driving cars work, they're going to game the system. So people who don't buy a self-driving car will just do whatever they need to do to be able to go faster, right? Or if they know that the self-driving car is going to be safe, then they'll make sure that they aren't safe because they know the self-driving car will just stop, right? So that people have been modeling this. Another issue is that there's going to be some time, especially if there are no regulations, where the self-driving cars cause more accidents because they're going to mess up. And Uber in particular has been having a lot of trouble this year. They are having more and more accidents. And so we can of course it's going to happen to some degree, but we shouldn't forget that that's the case. And the other thing I just want to bring up is, so let's assume for a second that it is the case that more lives will be saved. That isn't the only thing that matters, it turns out. This was a very recent survey. This was done this year, and more than half of people, 54% of people, said that they would feel less safe driving on the road if there are autonomous vehicles on the road. So that matters, and that's going to change how they drive, and that's going to change the whole ecosystem. So it's not that simple is all I want to say, that lives will just be saved. I think so, but it's not so simple as that. So this will move forward. Okay. There are many car companies out there, and I will say that especially in the past 6 months, some of them have been starting to change their minds. But there are still some who are saying it's a binary decision. Either we make cars that don't run into things, or we make cars that care about some of these micro decisions that Walter was talking about. We can't do both, and we won't do both. I don't like that, and I don't buy it personally, but I'd like to hear what the rest of you think. I don't think that you have to only do one or the other. It seems to me that it's a very reasonable and rational thing that you would have one team working on not bumping into things, and they have huge teams doing that right now, but that you in parallel can have another team that's thinking about how would we handle these types of situations, and the two teams would talk to make sure that the cars aren't going to be made in such a way that we can never address those issues if we want to. But now we'd like to know what you think, and we'd love to take some questions. Thank you.
Yes, let's give them a round of applause. So thank you very much. It's time to grill you. No, I'm teasing. We're going to be nice to them, all right? See where I'm even having Katie bring you water. Thank you, Katie. So the way Q&A works, show of hands if you have a question. Keep throwing your hands up every now and then. Katie and I will be moving around the floor with microphones. When we get to you with our mics, we'll hand it off, let you ask your questions, and hopefully carry on this pretty interesting discussion. So I've got one right in front of me.
Thank you very much for those great talks. One thing that I did not know that I thought was very interesting was that people might bully autonomous vehicles. That's very interesting. Here's my question. Part A and Part B. Part A is, my understanding is that Singapore has an autonomous taxi service. They got the technology from the US, I believe from MIT, and they've outcompeted Uber. And I'm just wondering if you have looked at this and if you know what's going on there and how it has evolved. My second question is specifically with regard to bullying. Is it possible you could have throughways for autonomous vehicles only? Okay.
Well, I'll answer the first one because it's easy. I don't know about Singapore. Very interesting. I'll look it up.
Yeah, I'm not sure how far they are with that either. But what was the second question again?
Bullying.
Bullying, yeah. And I think one concern is with the deployment of self-driving cars that they will actually be extremely conservative, right? So because every time that there's a crash with the self-driving car, well, that's certainly going to be in the news, as we've seen. So instead, they're going to set them to be very conservative, and there are going to be a lot of instances, I think, where a self-driving car just stops because there's a paper bag on the road, and it sees it's not quite sure, it's some kind of object, and it's just going to halt all of traffic, especially if nobody can intervene at that point. So I think that's actually going to be probably the more immediate problem to wide adoption, at least in contexts like cities where there's a lot of other human drivers going around. If you're in a more controlled environment, right, and the easiest would be some kind of theme park where you control all the vehicles and you can make all of them self-driving. That's easy. We can probably do now. It's just, the more ambiguities, the more human drivers you have in the mix, that's what really is going to make it hard.
And you can expect to see a publication from Vince in this, I'm sure, because there's a lot of game theory in this literature. But one other place that people have been thinking about this is, so it's both people who are driving, but also pedestrians. So a lot of the articles, especially the popular articles you'll see, are about pedestrians bullying self-driving cars. And so you'll see them talking about, there are some cities that are wondering whether they need to figure out ways to wall off pedestrians from the self-driving cars. Would they have to have certain pathways so that pedestrians couldn't see them? So that's one of the things that people are discussing.
Let me just say a quick word about bullying. One thing is about self-driving cars, they have sensors all around. And so if you start bullying self-driving cars, they can, presumably report their sensors. That's going to be in the data. And if there are laws passed against certain forms of bullying that are particularly dangerous, you're going to be a sitting duck to get a ticket because there's camera evidence. You also asked about creating special lanes or roads. I think that makes a lot of sense, at least during the transition period when it's, half and half, when the self-driving cars and the human driver cars are mixing. Maybe they'll get to use the high occupancy lanes, and then they'll be separated off. I don't know enough about the details to know whether that'll reduce accidents, but I imagine that some communities will probably try it.
Thank you for your presentation. My comment is mostly to Walter, but I'm interested in what all of you think. It seems like the ethical concerns that you raised come from a point of view that is, I don't want to sound wrong, but short-sighted, not on your part, but on our part. For instance, why would I want to own my autonomous car? Because people use their car for 30 minutes and then it sits idle for 8 hours, and they use it for another 30 minutes and it sits idle overnight. Why own it? We all want to use it. And then likewise, a lot of the concerns had to do with decision making within the autonomous car. But further down the road, maybe the decision's up there, not inside the autonomous car anyway.
So with regard to the first question about whether we're going to own them, I think that's a really good point. It's very possible that some manufacturer is going to just take those cars and quit selling them to people, own them themselves, rent them out, and you'll buy a monthly pass and just be able to call a car to pick you up when you want it. My suspicion is that that will happen eventually, and if you know the stock ticker for that company, let me know, because I want to invest in it. That will be a big money maker.
I think it's Uber. Well. Right, so the ride-hailing companies are definitely thinking about this, right? So Uber, Lyft, and already, I mean, some people maybe don't buy a car because they figure they can just get an Uber or Lyft, and that would, certainly if those could be self-driving, they'd be cheaper, and that would further reinforce that.
I have two members. I have two members in my lab already don't own a car and just use Uber to get around.
Yes, again, thank you for the really good presentation. My question is, could you expand a little bit about the gap in credibility of the companies, especially with Volkswagen and their diesel software hack? And this is going to be quite a bit more complex software, and it's probably going to be that much more proprietary, at least from the company's point of view. How are we going to trust them?
Might get myself in trouble with this answer. That's a great question. I'll have to think about how I want to answer it. The bottom line is, so what I alluded to at the end is that there are, I'd say a year ago, there was a very different feeling amongst companies than there are now, at least based on what they write. I don't know what's going on inside them. So what, in the past 6 months or so, I think that all of them have started generating technology when they're starting to realize exactly those problems. And so the Future of Life actually has brought together, which was this funding agency that Vince mentioned that helps fund our research as well, has been bringing together a lot of conversations, and it seems like over the past 6 months they've been changing quite a bit. And there are certain companies that we all know that are participating and certain companies that we all know that are not participating. So I think there's a lot you're asking there, and it needs to be asked, and I don't think they know the answers. I think that some companies are realizing there are a lot of problems here that need to be solved, and that they're probably be best if we do it together. But
there's also a legal issue here. Proprietary information. If these artificial intelligence systems in the cars learn from experience about how to avoid accidents and do a better job, then the question is whether that knowledge that's gained by the Mercedes has to be shared with Subaru and Ford and Chevrolet and so on. Well, whether they have to share that or not is going to be a legal issue for the legislature to decide. And there are obviously going to be arguments on both sides, but you could probably reduce accidents even further by requiring people to share information that's going to enable all the manufacturers to have safer cars.
And just to get back to the issue of verifying the code, at this point, if you looked at the source code and somehow tried to figure out, based on looking at the code, what kind of decisions it would make, it would be impossible. I think probably the best you could do is get it into some kind of simulated environment and see what it actually does. Which, of course, raises the concern that, like Volkswagen, if they can detect that they're in the simulated environment, that's maybe an issue.
The one other thing I'll say, we get to hear a lot about European laws because Vince is European and has a lot of colleagues there. There's also this interesting thing that that the regulations in Europe are likely going to progress much faster than in the US. And in Europe, you are expected to share a lot more as companies than you are here. So that's going to be another interesting trend to keep an eye out for and that companies will have to grapple with.
So I happened to be on I-40 this morning at 4 o'clock in the morning, no congestion, and listened to a program, I think it originated with the BBC, called Inquiry, and it was about precisely these topics with an emphasis on the ethical issues raised by what you the slide called the trolley problem. One of the questions that they raised was, or assertions they made, was that automated systems, AI systems, could develop their own ethical innovations. If I understood this correctly, that we think of the ethics that would be embedded in an AI system in a self-driving car as something that would be downloaded on the basis of some consensus or from experts, but that perhaps the assertion was made the systems could make progress on ethics on the basis of their experience and observations. And I'm wondering if you would want to talk about this possibility.
So that's another part of our project that we're working on, to try to build morality into a system that could then learn and maybe even do better than humans. It could do better than humans in a number of different ways. One way is that humans tend to overlook certain morally relevant features when they make moral decisions. That creates problems. They tend to not know the facts or not take into consideration the facts when they do problems, or they just get confused because it's so complex. And computers are going to be really good for that. But I totally agree with you that what we don't want to do is just take human morality as it really exists and build it into the computer. We could do that in theory, but I don't think we would want to, because our morality is filled with lots of prejudices and arbitrariness that on reflection we ourselves think, you know, shouldn't be there. And so our idea in our team is to start with human moral judgments and the features of situations that humans take to be relevant, figure out how humans weigh those against each other or see them as interacting, and then correct for the biases that people think, you know, should not be the basis for moral judgment. So if you do that, then the computer can actually guide humans and help humans do better in their moral judgments, because it's overlooking the different flaws. And in that sense, you might actually end up with a computer which is a pretty good moral guide. Now, that doesn't mean that it takes the choice away, because in the end, the computer says this is what you ought to do. You got to decide whether you're going to do it or not. In the car case, it's really fast. But if you look at some of the other applications of artificial intelligence, you're going to have time to say yes or no. Take, for example, right now in California, they're using computers to decide whether to give bail to defendants. And do we want to just take the computer's word for it and say yes, no, whatever the computer says? No, I think a lot of people are going to want to say, well, we're going to use that as guidance, but we don't necessarily stick with it. And there's going to be a lot of discussion of that as the artificial intelligence starts getting used in other areas.
That was a good answer. I think one more aspect. So a little bit of the question seemed to be about creativity, right? So can these systems be creative in their ethics? And there's different ways that they could be creative, right? One is that they just think of a different solution and just a different course of action that we hadn't even considered, right? But that we would easily consider to be, you know, if once we identify it, we say, oh yeah, that's of course the right thing to do. It's just, you know, dumb of us not to have thought about it. And that's a kind of it's a kind of creativity that we already sometimes see in AI systems, right? That AlphaGo in one of these games of Go had some very unexpected move that no human Go player would ever make that move, because it looks like a really bad idea, but actually, if you play it through, it actually works out pretty well. Another way in which you could have creativity is maybe that, I don't want to say that they develop their own theory of ethics, but maybe they develop their own conventions, right? If you have a lot of self-driving cars on the road, maybe they reach a kind of different equilibrium amongst themselves as to when they get out of each other's way. I don't know if I would call that, you know, as per se an innovation in ethics or morality, or just a different solution as to how to proceed, or a different equilibrium, but that certainly could happen.
So the car is going down the mountain road, and it turns around the corner, and it sees the person in the road, and the car says, oh, I'm going to like move and go up on two wheels and go between the person and the wall. It's like, I never would have thought of that. Yeah, it's a creative solution.
but you could do it.
I have an answer and a question. I drive 1,000 to 1,500 miles per week. I have sales stuff in my trunk, in my back seat, and sometimes in the driver's passenger side. I want to own that car. I don't want to pull stuff out every single night. The question that I had was, I've checked out the moral machine, and I hate it. Because it asks, do you hit the wall, or do you hit people? You're in a car that has no brakes. Okay, you hit the people. And 2 blocks later, you have to make the same decision. And 2 blocks later, so how do you stop the car? And why is that question not figured into that scenario?
So I actually agree with you. I think the moral machine thing is a fun, it's a fun game that makes you think about what your different values are and so on. But it leaves out a lot of the realistic things. You either hit these people or hit those people. Whatever happened to probabilities, right? I mean, that's a big part of life. So we actually have been focusing more on kidney exchanges and who gets, kidneys in the hospital. It is a realistic situation. You have to make decisions, at different points about the distribution of kidneys to different people who are viable candidates for the kidney. And then I think you get it more realistic. So I think the moral machine is a fun game, and I still recommend that people go to it and you find out something about your values. But as a guide to how we actually ought to program the cars, I'm on your side. I think it's unrealistic.
The only thing I'll add to that is that there are some people trying to make virtual reality versions of the moral machine. You can't get millions of people to respond to that, so that's a different story. But there are people, I think everyone knows it's not the most realistic thing. It's still very useful, and the information is very useful. And so I think your concern is exactly the type of thing where people are trying to come up with ways to make it more realistic and trying to solve that problem.
Hi. I'm sorry. Did you want to respond to that as well?
I was going to say there are kind of two ways in which it's unrealistic. One is that the way these systems are programmed right now, it wouldn't actually, even if you had the answers to the right kind of questions, it wouldn't be that easy to get that into the system. So that's one way in which our kidney work, I think, is more realistic. The other way is what Walter said, that in reality, it would never be quite that black and white. There would be some probabilities that you might, if we go this way, we might hit this person, we might not. But it's not clear necessarily that those are the questions that you want to ask of people, because people are not good with probabilities. Computers are actually quite good with probabilities. They're just not very good with ethical judgment. So if you can kind of separate it out, maybe that is the right thing to do. Maybe we want to ask people questions that don't involve probabilities, because maybe that's not what they're the best at. Sorry.
So my question is about more about how the cars could be used in the future and who actually has to be in the car. So I work at a K-8 school, and one of the biggest challenges around dropping off and picking up kids from school, because there is no bus at the charter school where I work. And so is it possible that you could fill up a car with kids? Because does it really need to be an adult in the car if you're talking about picking up and driving and dropping off children? Also, I'm thinking about, recently I heard about Amazon wanting to have access to your trunk so that they could drop off your packages in your trunk, and that way you don't have to worry about people stealing stuff off of the front of your porch. So I think about the amount of groceries and Target and things that could be picked up, like actual errands that my car could be doing for me, so that I don't have to, when I get in my car later, it's gone to the grocery store and to Target and so on and so forth, and now I've got a car full of things that I needed to do and more time for myself. Or so I guess I'm asking what sort of questions are being asked around who needs to be in the car at the point that AI takes over, and also what are we doing to avoid that doesn't become used for the forces of evil, for instance, drug running, and or even the idea that a pedophile could send a car out or hijack a car that's full of children. And yeah, sorry.
I think the answer to the first question is, how much do you trust the kids? Because they could probably have a lot of fun in their autonomous vehicle.
Exactly.
The second question, I think, touches on something interesting, which is it kind of gets back also to this idea that, well, maybe nobody needs to own the car, right? Maybe in the end it turns out to be more about everybody having certain permissions, right? Just like you have permissions to go into a certain building at your company, and maybe within the building there are certain rooms you can access and others that you cannot. Maybe it will be somewhat more like that vehicles and other systems, you get certain permissions. You know, Amazon has permission to get into the trunk, you have permission to get into the front. It's not clear to me how that would all work out, but certainly those would start to be options. And then we have to think about what the consequences of those options would be.
So I have a very different reaction to this idea that there be a car picking up the 4 kids from the school and there's no adult in the car. To me, that is horrible, because I had the best conversations with my kids when I was picking them up from school, because it's me and them, and they can't get away from me. They can't dodge, go into their room, turn on their, that's it. It's like, you got to talk to me, and we had wonderful conversations. And so, but that's a good example of how the technology comes into our lives, and at first it seems so efficient and so nice, because now we don't even need an adult in the car, and I don't have to pick up my kids from school. Now think about it, how that's going to affect your relationship to your kids. So we've really got to think through all of those issues before we start, you know, changing our societies in ways that might turn out to be more serious problems.
Hi, great talk. This is more of a comment. I did programming myself for quite a few years. You have to include edge cases. Otherwise, you're going to get a program that locks up, crashes, and all of a sudden, you don't want a car that, you know, doesn't know what to do when it encounters a set of circumstances.
Obviously, I'm glad to hear you say that. I'll just leave that. I obviously agree with you. And that's been my experience in all of my programming, in all of my engineering. If you don't think about those edge cases, you will regret it. That's my experience.
So unsurprisingly, I'll also agree. There's another aspect to that not only will you sometimes run into the edge cases, but also if your code doesn't solve the edge cases correctly, you probably haven't thought very carefully about how to design the code in the first place, and you probably missed some other cases as well.
I'd like you to comment on 2 issues. One, the difference between its appropriate usage in urban and suburban areas, and then secondarily in more rural areas. And then my other thought that I'd like you to think and share with me about us is that more sophisticated, educated people are going to have one view of the use of this, and yet there are people who are going to be against it almost on a Luddite basis and aren't going to be actually informed as to the truth or validity of what autonomous cars and machines can do. They'll be operating from, you know, the fake news that they get. And I'm wondering, how do we deal with that?
So make sure I remember both questions, but I'll start with the urban versus rural. So some companies are taking that into account. And one thing I didn't have time to say is that it's unclear what incentives will change car companies' behavior. You can imagine many. Legal could be one, but so can buying power. So Tesla is already taking this into account. So they used to be programmed up to not be able to go above the speed limit. And the people who bought the cars were so angry, and in fact, if you look at the popular press on it, they say there was a Twitter storm about it, and it changed Tesla's mind. And so they currently have a rule now where in urban areas you can go 5 miles above the speed limit, but in rural areas you can go up to 90 miles an hour, regardless of what the speed limit is. So that's just one example, but there are certainly companies thinking about this, and as a running theme, we all have to think about these things, and they did that because of customer demand. So that suggests that at least some customer base wants there to be differences between the two. So it's a great question. The other question was, what was the other question? Luddites. Oh, what do you do with Luddites? I'll answer that in a slightly indirect manner, which is that one part of our project that we ended up spending quite a lot of time on that we didn't expect, is what makes people want to use something like AI in something like a self-driving car and what doesn't. And it seems like right now, the number one thing, everything else we've tried, and we had theories about failed, but is experience. So seeing it work, also thinking that understanding it's a complicated problem seems to be what we've found to have the best, most power to change people's opinion about whether they would adopt it or not. So we'll see how that research goes, but that might be one avenue to pursue.
I'll just add that it's nothing new having to run into Luddites, right? I mean, when cars first came, the people who rode horses were worried about the cars. And, when airplanes came, people thought they were going to fall out of the sky on their houses. And once you get used to it, then it'll happen. One good thing about the United States is we got 50 states. So one state, lets this happen. When there are more Luddites in the other state, well, they're going to see that state doing just fine, and then they won't be so opposed anymore. So it can get phased in to deal with the Luddite problem.
Okay, I'm wondering about how the machines actually do some of the learning. For example, in this year, there was a victory of the machines over just video gamers. There was a video game that was given to the machines, and the machines figured out what the video game rules were, wasn't told anything, nothing really went into it, and it beat the best in the world, just figuring out what the rules were by itself. So what I'm wondering is, where do self-driving cars and similar technologies get their learning from? Where do they get their information from? And how hard really is it to change that if they get the rules wrong? I mean, how do we know we're not going to get self-driving cars with road rage?
So there is this whole field of machine learning, which is often kind of seen as a subfield of AI. And there, the idea is that there's different forms of learning. The simplest version is what's called supervised learning, where we get a lot of examples that are labeled, and then the software has to generalize to the future. So you can think about like image recognition. I show the software a lot of pictures and say, okay, you're in this picture, nobody is in this picture, you're in this picture, you're in this picture. And then I show the software another picture and say, okay, are you in it or not? So that's the simplest kind of machine learning problem that by now we have really good algorithms for. And that's where a lot of the recent developments in AI that's where most of the recent progress in AI has been, is in these kind of learning problems through what are known as artificial neural networks, which is a technique that's actually quite old, and it seemed to have been superseded by other techniques, but somehow made a roaring comeback and is now doing really well. The downside of that is it's a particular technique where the outcome is very difficult to interpret. So you get this network, which is a bunch of weights on edges that somehow produces the right outcome, and it's very hard to figure out exactly what it's doing. So that's actually kind of an interesting aspect of a lot of these algorithms, right? That, with AlphaGo, it's also, in some sense, it's harder to figure out what AlphaGo is doing than what Deep Blue is doing. But that's in part due to the particular kind of algorithm that's being used. On top of that, there's something known as reinforcement learning, where not only do you have to classify things, but you also have to take actions in the domain, right? Like actions in a video game or out in the world, like a self-driving car. And that requires some specification of rewards that you say, okay, if you get to this state, you've done a good job. If you've gotten the car to the final destination without banging it up too much, you get a reward. And by letting it try that many times, maybe in the real world, but maybe ideally first in the simulator, it eventually figures out good policies, what to do in various circumstances, and then it can deploy those policies. That's a very quick summary of the kinds of techniques that go into some of these systems.
Let me just add that when Vince says it tries it many times, it means many times. I mean, like what AlphaGo played itself in the game of Go like 1 billion times or something. I mean, it was just unbelievable, and it did it, you know, like in a very short period of time. It doesn't have to wait for the human to like make a move on the other side. And the same kind of thing would happen with cars if you had careful, you know, video. So when these cars enter a new area, they drive around, take video of the streets. They know what the markers are to enable them to react to them, and then they can simulate driving in and out the streets 1 million times in an afternoon. And by the end of that afternoon, they figured out pretty good plans for getting around. Obviously not perfect. Then you have to add more data from more experience as the cars drive around the roads and turn into new things. But it's really the same way we learn. I mean, how did I learn chess? I played hundreds and hundreds of games, you know, and got pretty decent. I never got very good. But it's through experience and learning and trial and error that they become so good at it.
Let's give our guests a round of applause again. So I have a surprise for all of you and you. Joining us tonight here at the Science Cafe, we have a group that calls themselves the Living Poets, Living Poetry. And they have joined us for tonight's cafe. What they do is they show up at the Science Cafe, and during the presentations, they write poems about the topics as they are moved and inspired. So I'm going to go ahead and invite them up. They're going to share their artistic pieces with us and introduce themselves. So I'm going to pass off the mic.
All right. livingpoetry.net. We're the largest collection of poets and poetry readers in the Triangle. Go find us if you have it all interested. We run monthly workshops, open mics, all sorts of fun stuff. So this is my poem for tonight. Oh, and what is my name? Oh yeah, I'm Bartholomew Barker. BartBarker.net. Install an AI in my car tonight. I'm ready to be chauffeured home by algorithms and sensors. I get my best ideas while driving, but I forget most of them before I park. Imagine how good a poet I would be if I could write and revise while traveling through lush landscapes or watching the full moon rise beyond the trees. But maybe the act of driving is what fuels my creativity, even more than wine. I'll leave that for the traffic network of AIs to figure out as we approach the singularity together.
Thank you, Bart. I am Tara Lynn Groth at taralynngroth.com. So my poem is First Step. Roads are the grid of a new chessboard we have to play. Our digital friend knows our faces, our voices, the small moves we make as a pawn. While we try to cross this checkered street, driverless cars hum past, bars open on each corner. With no need to work anymore, happy hours become happy days. Parking lot forests grow around artificial morals. Roots roll pavement, ready to trip anyone who tries to walk.
My name is Anna Weaver, and my title borrows from Gabriel Garcia Marquez. It is Road Rage in the Time of Driverless Cars. My friend and his cousins learned to drive from their grandpa, who cursed each of them for a week in turn. Gas it, you yo-yo! Hard to say if making that story obsolete is a loss, or whether a computer could learn that way. All I know for sure is that I would miss the satisfaction passing a headless, eyeless, emotionless, driverless driver, knowing it could not savor the singular indignation of my middle finger as it processes the value of my organs and fails to imagine either Thelma or Louise as one of us yo-yos gasses it right over the cliff. But at least I'll have 2 hands free. 2 birds in flight.
Fantastic. So thank you to all of you for being here. Those are gorgeous. I love it when poetry comes to the Science Cafe. Let's give our 3 guests a round of applause again. Thank them for coming tonight. Great work. And thanks to all of you for coming out on a Thursday night to the Museum of Natural Sciences. Next Thursday night, I hope you'll join us again. We're going to be joined by someone, I forgot her name, from UNC, Samantha Brody. Thank you, Katie. Samantha Brody is going to be here in the Science Cafe from UNC talking about postpartum depression. We hope to see you next Thursday night at the Science Cafe, 7 p.m. right here. Good night, everybody. Drive safely.